Hey guys, this is Stratton. So I just wanted to answer the questions that you asked in response to our notes that we did last week, our atoms and elements notes. Before I get into some of your answers, what I want to do is talk about the way you responded. So if you looked at our instructions here, it said to answer the two questions above using complete sentences. Okay, you guys are in 7th grade. You have been required to answer things in complete sentences for a while now. This is something you know how to do. We know in 7th grade that every sentence starts with a capital letter and ends with some kind of punctuation. In this case, it's almost always going to end with a period or with a question mark. So, I'm looking through here, not calling anybody out, but I saw lots of things that started with a lowercase letter, had no ending punctuation, didn't capitalize the letter I. Please make sure you are answering those things like a 7th grader would. All right, so let's go ahead and move on. So our topic was atoms and elements. So I had a lot of different questions, and I've sort of condensed them down into a couple main threads. So one question that I got that I thought was a really great question is, if our atoms are made of only 3 different things, protons, neutrons, and electrons, why are they different? And that's actually a really awesome question. And honestly, it's kind of hard to explain in a 7th grade classroom. But the easiest way to explain it is because of the kinds of bonds that different elements are allowed to make. So really what that means is the number of electrons that an atom has and how it interacts with other atoms sort of controls the property of those atoms. And we'll see trends in that when we talk about the periodic table. So I know that's not a full answer, but it's the best answer I've got at our 7th grade science kind of level. Next, I had several people asking about electrons. So I had some people who were concerned that electrons are rounded off of the mass. And that's because they're really, really, really small. We talked about electrons being 1/1850th the mass of a proton or a neutron. And I understand why that can be confusing. Because, let's be honest, our models aren't accurate. Our models are not accurate. So when you look at a model like this, it looks like it's the same size. But these models are created so that we can see them. When we watch our How Small is an Atom video, you know that electrons are so far away from the nucleus, and our nucleus is so small that if we did it at a scale we could put in a textbook, that it wouldn't fit, and we wouldn't be able to see anything that we needed to see. So in reality, these electrons need to be much, 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 much smaller than the protons and neutrons. So that's why we round them off, because if we were to put that on as a part of the mass, it would come to, let me get my calculator really quick. It would be 5/10,000ths of an atomic mass unit. And so even if we had lots and lots of them, it would just be rounded off when we look at our atomic mass. So that's the reason that we don't include electrons. It's because they're so small that they would just be rounded off when we count up that atomic mass. Because our protons, our positive protons that are in the nucleus, our neutral neutrons that are in the nucleus, they are one whole atomic mass unit. These electrons are so much smaller that once we tally everything up, the number is just going to be rounded off when we round our decimals, like you know that we do. All right, so let's look at one of our boxes on the periodic table, because by and large, I don't think our issues were with our issues were not with the atom itself, but more with trying to read the periodic table. So let's pause for a second. Sorry about that. So a lot of you had issues reading the the box on the periodic table. That's something that you guys were concerned about. So let's look at this box we have here. So All of our elements obviously have their own name. Some of the elements' names are more modern, things that have been named more recently. Some of these have even been named in, my lifetime. Um, so let's look at magnesium. Magnesium is an older element. So it has an English name, and its elemental symbol, its chemical symbol, comes from the English form of the word. Now, we do have some that have chemical symbols that come from other languages, and that's just because those are elements that we've known about for a longer amount of time. We've known about gold for a long time. We've known about iron for a long time. So we based those chemical symbols on another language. There's really not necessarily a rhyme or reason to how it's done. That's just what was decided when we were putting the periodic table together, and we'll learn more about that process later. Probably the biggest question or the most common question I had was this guy right here, this box in the upper right-hand corner of the periodic table. Now, what we'll learn is that not all periodic tables are exactly the same. They don't all carry the exact same information. Almost all of them are going to have your chemical symbol, your name. Most of them are going to have your mass. Almost all of them will have your atomic number. But you'll also have some that have different types of information. This one happens to include the state of matter of our element. So magnesium is a solid at room temperature. So this depicted a solid. If it was a liquid at room temperature, it probably would have had a raindrop or something like that. And if it was gas, maybe it would have had a cloud or something like that. So that's not something you're going to see terribly often, but there it is. All right, so the atomic number. Now, the atomic number is determined by the number of protons in your element. Magnesium will always have 12 protons. No questions asked. If it's an element with 12 protons, it's magnesium. Okay? Now, most of the time, we're going to have the same number of electrons. So most of the time, magnesium will have 12 electrons, but not always. Not always. So this atomic number is determined by the number of protons. Our number here at the bottom, our atomic mass. I had some people who were confused about why it's a decimal, and that makes sense because I told you in our notes video that we can't have pieces of parts of protons, neutrons, and electrons, and that's true. That's because this number is an average. So what that means is sometimes we have 12 protons and 12 neutrons, but sometimes we have 12 protons and 13 neutrons. So what they do is they take a sample and they come up with the average mass. That's why this is a decimal. I'm sure that you've been finding averages in math class before and you come up with a weird decimal that doesn't necessarily make sense. And that's kind of what this is. So this is just an average number. And density, that's another question we had. So I had a lot of people who were confused about the density of a nucleus. They gave us that really sort of bizarre illustration in our TED-Ed video that showed us that the nuclei of 6.2 billion cars, if we put all of those into a 1 foot by 1 foot box, that would be the same density as a nucleus. All you really need to take from that is that a nucleus is denser than anything you can think of. I'm not going to expect you to be able to come up with an exact numerical representation of how dense a nucleus is. I just need you to understand that it's extremely dense, and that's where almost all of the mass of your element is. All right, ladies and gentlemen, I think I have hit most of your questions. As always, if you have any other questions, I'm always here to answer them. I'll talk to you later. Bye.